Today we will see the properties of DFT. We have periodicity property, linearity property, circular shift of a sequence, circular property, time domain. We have circular frequency shift property. Next is symmetry property of DFT. Then there is time reversal property. Then you have circular convolution property. You have multiplication property of two DFTs. Then you have circular correlation property. Then you have Parseval's theorem. So this is related to power. To begin with the properties, one, we'll go for the periodicity property. The periodicity property states that if x of n and capital X of k are n-point DFT pair, then x of n plus n is equal to x of n for all n's, and x of k plus n is equal to x of k for all k's. So we want to prove this. So in this proving, from definition of DFT, we have x of k is equal to summation n is equal to 0 to n minus 1 x of n using twiddle factors. This is Wn nk. I will call this equation number 1. Now K is having all the values from 0 to n minus 1. N is also having values from 0 to n minus 1. Let K is equal to the new value of K plus n. Add a value of n in that and you get a K, new K. So how will you do this? My left hand side will be x of K plus n. Replace this K by K plus n. This is equal to summation n is equal to 0 to n minus 1 x of n wn n. I will be replacing the K by K plus n. This will be split as, it will be split as x of n, because this is raised to, we can have it split as nk raised to n n. This is equation number 2 we can have. Now we can see that wn. What does this mean? Now we know that wn is raised to minus j 2 pi by n, and this n is n times n. Okay, so this is your wn raised to n. Now I can have the simplification. Now this is nothing but e raised to minus j 2 pi n. Now this is nothing but cos of 2 pi n minus j sine 2 pi n. You have any value of n, you will always be having a 1. Therefore, wn raised to nn is always 1. This is what is the factor which helps us with the periodicity property. So now, if I put this equation 3 in equation 2, from equation 3 and equation 2, we have x of k plus n is equal to summation n is equal to 0 to n minus 1 x of n wn nk, and this becomes 1. Okay, so this is equal to summation n is equal to 0 to n minus 1 x of n wn nk x of k plus n. So what does this mean is same as x of k. Therefore, x of k plus n is equal to x of k. This is what the proof is, hence proved. Now one more simple property we are going to go for, linearity property. It states that x1n is a DFT pair with, suppose xn is a DFT pair with xk, then x1n also having the DFT pair with x1k, x2n DFT pair with x2k, then a1 x1n plus b x2n will have the DFT pair as a x1k plus b x2. This is the property.